All right, so let's go through rectangular hyperbolas. Now, this is an equation in the form of y equals to 1 over x, or x to the power minus 1, right? Because remember, negative power is 1 over the positive version of the power. All right, so let's try to construct a table of values for x and y. We'll try to plot those points here. The first one would be 0, right? And then we start going a little bit more than 0, so let's go 1 quarter, and then 1/2, and then 1, and then 2, and then let's say 4 here. All right, now see that when you try to do when x is 0, y would be 1 over 0. You can't divide by 0, so this one wouldn't exist. There's no point here, and we'll get back to that in a second, the reason why there's no point here, and what is that called in the graph. Now 1 divided by 1 over 4. Okay, we'll go back to these ones later, but 1 divided by 1 is just 1, and 1 over 2 is just 0.5, and 1 over 4 is just 0.25. Okay, now for this value here, 1 divided by 1 over 4. So remember, the formula can be written as x to the power minus 1 as well. So let's have a look. So that will be 1 over 4 to the power minus 1. So note that negative power just means 1 over the positive power, but also means the reciprocal. Alright, so the reciprocal of that is actually just 4 over 1 to the power 1. So the answer here is just 4. Okay, another way to think about this is if you have 1 over 4, that would be 4 to the power minus 1 in the brackets and 2 to the power minus 1 again. So then you would multiply the 2 power, and so you get 4 to the power positive 1, which is 4. In either case, that would be 4, and when you do the same thing, that to the power minus 1 would be in the reciprocal of that, so that would be 2. Okay, and then let's just try to sketch these parts out first. So x and y. Let's see. Okay, so 0 here, that's the x-axis, that's the y-axis, and then we've got x is, let's say 1 is here, 1, 2, 3, and 4. So then this would be 1/2, that would be 1 quarter. Okay, and the y-axis would be 1, 2, 3, and 4 again. So the first point is 1 quarter on x, which is this one here, 1 quarter, and then 4 on y. So that point would be somewhere up here. And then 1/2 and 2 would be around here. And then 1 and 1 would be here. And then 2 and 1/2 on the y-axis is around here. And then 4, 1 quarter on the y-axis would be around here. Let's have a look at this shape here, what we've got so far. Okay, so it looks like a curvy part, but at this point you should notice two things. The first thing is that as x gets larger, let's say x is 10, right? The y value would be 1 over x, which is 1 over 10, and that would be 0.1. Now this is really close to 0, right? It would be like really close to 0, but can it ever be equal to 0? Not really, because when x is equals to, let's say, 1 million, right? Y would be 1 divided by 1 million. And this would be 0.000, a bunch of zeros, and then 1 at the end. But it's still not 0. It will be very close to the x-axis, right? Close to the x-axis, but it doesn't actually touch the x-axis. It's only close to it. Okay, and now we can say that as x, and therefore we can say that as x goes to it, as x tends towards infinity. So x becomes a very large number. Y would tend towards 0, but it's not equal to 0. Note that this is not equal to 0, because x can't be infinity. There's no such thing as equal to infinity. So then y would get closer and closer to 0. Now this thing means that the y equals to 0 is the asymptote. Okay, the first time you see the concept of an asymptote. An asymptote is the line that the graph approaches as x tends towards infinity in this case. Okay, so as x tends towards infinity, I'll go through that again. As x tends towards infinity, okay, so x gets larger and larger and larger. The line will just keep getting closer and closer to the x-axis, but it will never touch the x-axis, which has the equation of y equals to 0. Right, so y gets closer and closer to 0, but it can't be equal to 0. So y equals to 0 is the horizontal asymptote. Horizontal asymptote. Okay. And then let's look at the direction where x gets closer to 0. So note that when x is 1 quarter, right? When x is 1 quarter, y would be in the reciprocal of that, which is 4. right? Then do you see a pattern here? When x is equal to, let's say, 1 over 1,000, this is really small number close to 0, y would be 1,000. So in fact, this graph on that side will just go larger and larger and larger and larger as x gets closer and closer to 0. But does it ever cross through the y-axis? The answer is no, it doesn't cross through the y-axis. Because if x, so as x tends towards infinity, then y would be 1 over x, and this one would tend towards 0. Right? Because when x is a really large number, 1 divided by a large number is really close to 0, but it is still not 0. And so, as my bad, it was as x tends towards 0, y would be 1 divided by a really small number, right? And then you would flip that around. So you see, you would flip this 1 over the really large number around into a, y would be 1 over a really small number, my bad. So 1 over a really small number, flip that number around, and then you would get a really large number, so it tends towards infinity. Okay, so then we can say that as y tends towards infinity, one of the asymptote is that x is equals to 0. Okay, so there are two asymptotes. The first one is the x-axis, because the graph will never cross to the x-axis, but will approach it as x tends towards infinity. And then it will also be the y-axis. As x tends towards 0, the graph will get closer and closer to the y-axis, but never cross through it. And if you notice, the negative region will be the same, x and y. So if it's negative 1/4, then y is just negative 4, right? So it's just somewhere really close down here. And then when x is negative 1/2, y would be negative 2, which is like around here. So in fact, the shape in the negative x region would just be almost the same, right? But it's just in this other quadrant here. So in the positive x direction, the shape of the graph will look something like this. And then in the negative direction, it will look something like this. Okay, so in summary, the rectangular hyperbola, hyperbola, okay, in summary, the rectangular hyperbola will have the shape of, so that's the y-axis and that's the x-axis. So we have the shape of something that looks like that and then like that. Okay, and the asymptotes are they are x equals to 0, which is the y-axis, and y is equals to 0, which is the x-axis. Okay, and next let's have a look at some translations of this graph here. So far we've got the graph, and there are two types of translation. There is the horizontal translation, right? Horizontal translation, and a vertical translation. All right, a horizontal translation and a vertical translation. So when you're translating a graph horizontally, in this case, let's say that graph, if we want to translate that to like shift it over to this side here, so that the graph now looks something like that. Okay, let's say we want to translate it horizontally, because originally it's centered around here. Now we shift it horizontally. Let's say the new asymptote is x is equals to positive 3. Right, now note that horizontal translation is a little bit opposite. So instead of, okay, so you would replace the x value, and if you translate to the right by 3 units, then the x value would be replaced by x minus 3. Right, now I'll show you the vertical translation first. So if we translate it vertically to somewhere around here, where the new horizontal asymptote is y equals 3, then the shape of the graph will look something like this. Okay, so we translate it vertically up. Okay, so this is the vertical translation of the graph, upward by 3 units. Then the new equation would be y is equals to 1 over x, and then you plus 3. All right, so let's analyze this. You see how when we're translating it up, the vertical translation, you're adding the translation amount, which is 3, to the entire function, right? Because the original function, I'll write it here, the original function is y equals to 1 over x. Right? If you add the 3 to the entire function, you're shifting it in the y direction. And if you shift it up, then you add those values. If you shift it down, then you minus. Okay? But the horizontal translation is a little bit opposite. If you are shifting the graph horizontally, you're replacing the x value with x plus and minus something. All right? And if it's shifting to the right, then you need to minus, because the idea is that to get the same y value, you need to have a value that is 3 more than the original. So that when you subtract the 3, you get the original x value. Okay, so don't worry about that for now. Just remember horizontal translation, you replace x with x plus or minus something. And then the vertical translation is when you add a like a constant term. All right, for the vertical translation. All right, here I'll show you guys the graph of y. So right now, given this function here, because a is 0 and b is 0, right now the graph is 1 over x minus 0 plus 0, which is just 1 over x. Okay, so this is the graph, the very basic graph of 1 over x. And then let's see what happens when we change up the a value here, right? So x minus a, yeah? We change up the a value. If we make it positive, then it will shift to the right. If it's negative, it will shift to the left, because we're writing it in terms of x minus a. So if a, so right now, if a is, let's say, positive 4, okay? And then the new horizontal asymptote is y equals to the a value. Okay, so right now a is 4.5, right? Somewhere around here. So if you notice, right now b is still 0, so that one is still gone. But now the equation is y equals to 1 over x minus 4.9. And I said before, you see how the vertical asymptote, which is this line here, right? This line is the vertical asymptote, and it is at x equals to 4.9. Okay, which is this one here. X equals to 4.9 is the equation of this line here. Okay, and then if we want to shift it up, we'll need to change up the b value. So let's say this is plus b, so we'll shift it up by around 6 units here. Okay, and then the new horizontal asymptote will be y equals to b, which is y equals 6.4. So yeah, so now the equation is y is equals to 1 over x minus 4.9 and then plus 6.4. So looking at this, I can tell that it is shifted 4.9, but negative. When you're minusing, you're shifting to the right, right? Whoops. So 4.9 to the right and 6.4 up. Okay, so you see this is originally the center, it was here, right? So shift 4.9 to the right and then 6.4 up. Right, so that's how you can deal with the vertical translation, horizontal translation of rectangular hyperbolas. Okay, let's have a look at this graph here. So again, we need to write this plus 1 in terms of minus something. So y would be 2 over x minus minus 1, and then minus 3. So if we write it this way, then we can easily read that. Okay, this is minus 1 translated 1 to the left, right? Or if you keep it as plus 1, then remember the horizontal translation is a bit opposite. Plus 1 means 1 to the left. Okay, so this is 1 to the left, and then the minus 3 is 3 down. Okay, so remember the original asymptote is just the x and the y axis, and 3 down means that the new asymptote is y is equals negative 3. And then 1 to the left means the new x asymptote, vertical asymptote, would be x equals to negative 1, because 1 to the left, right? 1 over to the left here, and then 3 down. And then the shape will be, we can determine the shape by finding out, for example, the y-intercept. So let x equals to 0, then y would be 2 over 0 plus 1 minus 3, which is then 0 plus 1 is 1, 2 divided by 1 is 2 minus 3, which is negative 1. So this is the y-intercept. The y-intercept at negative 1 is somewhere around here. Okay, so we just need to make it pass through this point. And to make it pass through, well, the negative region, is just going to look like that, right? It will barely touch it will get close to the asymptotes, but can't touch it. And then in the positive region, it will start somewhere close to this asymptote, and then has to cross through the point negative 1, and then gets close to the other asymptote. Okay, so this is the graph of y equals to 2 over x plus 1 and then minus 3. All right, now this graph is a little bit different. The coefficient is negative, the factor is negative 2. This means that the graph has been reflected. Okay, if you have a negative number times into the function, so let me give you guys a quick review. So y equals to 1 over x would be the shape that looks like this, right? But if you have y is equals to negative 1 over x, that means that this is reflected in the, we can reflect in either way, x or y axis, it will be the same, but then the shape will be like this. Okay, so instead of in quadrant 1 and quadrant 3, it will be now in quadrant 2 and quadrant 4. Because when you reflect this one down, it will look like that, and when you reflect this one up, it will look like that. Okay, either way, if you reflect this one to the left, it will look like that, and reflect this one to the right, it will look like that. So the blue lines is the new equation when you have a negative factor multiplied into the equation. So let's see, negative 2, there is no constant term, which is no, so this is no vertical translation. Right, no vertical translation, which means that the asymptote, right, the horizontal asymptote will just be at y equals to 0 is the asymptote here. So horizontal, right, asymptote is y equals to 0. Okay, but now we have x minus 1. So when you minus, when you change x into x minus 1, this is translate 1 to the a bit opposite. If it's minus, it's actually to the right. Okay, so 1 to the right means the vertical asymptote. Vertical asymptote would be x is equals to positive 1. Okay, so x is equals to positive 1, and then let's sketch the graph now. So x is equals to positive 1 is somewhere around here. All right, so x is equals to positive 1, that's a vertical line, and then we need to, so this is reflected, which means that instead of looking like that, it will be reflected, and the first line will look like this. Okay, and the second line will have to be something like this. We need to find out what the y-intercept is. So let x be equals to 0, then y would be negative 2 over 0 minus 1, which is negative 2 over negative 1, which is positive 2. So that's just positive 2. That's the y-intercept. And this is the equation, y is equals to minus 2 over x minus 1. Okay, so quick recap. The negative symbol means that it will be reflected. So now it looks like that as opposed to the original equation. Okay, and then when x, the original equation is 1 over x, when it is replaced by x minus 1, then that means that it's translated 1 to the right. So the new vertical asymptote would be this one here. Would be this vertical one here at x is equals to 1. That's a new vertical asymptote. But the horizontal asymptote is still the same. It's still the x-axis, and the x-axis has the equation y is equals to 0 as the horizontal asymptote. So remember, rectangular hyperbolas always have two asymptotes, a vertical one and a horizontal one. Okay, and the shape of the graph will just flow around the two asymptotes.